Hello, my name is Ogi Mirjanovic, and I am Undergraduate Programs Director in the Department of Electrical and Electronic Engineering at the University of Manchester. Today, I would like to talk to you about one particularly important application of electrical and electronic engineering that is absolutely critical for our society and civilization as a whole. In particular, I want to talk to you about the challenge of providing energy when it is needed and where it is needed, but also energy that has been produced and consumed in as environmentally friendly manner as possible. Let me just pause here and reflect on the fact that electrical energy is absolutely crucial in our everyday life. We use it to power most of the devices we have at home, pretty much all our gadgets, computers, phones, iPads, Xboxes, PlayStations. The importance of electrical energy is true today just as it was true 30 or 40 years ago. So what has changed? Well, what we would have had 20 or 30 or 50 or even 100 years ago is a small number of large so-called power plants that produce all of the electrical energy using generators, which are machines that convert mechanical into electrical power. These few large producers of electrical energy would be typically powered by fossil fuel or Earth's gravity acting on water in the case of hydropower stations. This huge amount of electrical energy would then be transmitted over very long distances across countries and continents with mind-boggling speed and extremely high efficiency. To individual consumers, where it is converted to heat or light or sound or mechanical work or in fact used in its electrical form. However, in recent years, power systems have undergone dramatic changes, and these will continue long into the future. The key driver behind all of this is the global humanities challenge of tackling climate change. Essentially, we want to move away from using fossil fuels to produce electrical energy, but also we would like to move away from using fossil fuels to provide us with heat, as well as power all kinds of transportation vehicles, from motorbikes to aircraft. This is actually quite a big challenge because we are in effect fighting climate change on two fronts by changing how we produce electrical energy, but also how we consume energy. So let us firstly think about the new producers of electrical energy. Prime examples of these producers are solar panels that convert solar energy from the sun and wind turbines that convert wind energy. These producers are ideal from the perspective of their energy source, which is, in practical terms, inexhaustible. However, there is one major challenge with them, and this major problem is that we have limited or no control over the amount of energy that these guys produce at any point in time. This is, in essence, one of the main issues with most of the renewable energy producers. In our department, there is a large number of projects across various subdisciplines of electrical and electronic engineering that are looking at improving efficiencies of solar panels and wind turbines, but also methods of better control and coordination of these renewable energy sources. Fields such as telecommunications and control systems, as well as electronic semiconductor materials, contribute to addressing these challenges. To help address the problem of lack of control over the amount of renewable energy produced by the renewable energy sources, we use energy storage devices, basically batteries. They allow us to save energy when we are producing more than we are consuming, and then we can use that energy later on during the periods when our consumption is greater than production. Once again, within our department, we have several current research projects that are looking at how to optimize operation of these batteries in conjunction with renewable energy sources. Adding to this new paradigm are the energy consumers that tackle climate change by switching from fossil fuels, and probably the best example of these is electric car. These electric cars would have significant impact on the global emissions of greenhouse gases but are also representing a challenge in terms of providing large amounts of electrical energy that they would require, as well as electronics-based control and monitoring technologies that would allow them to be as convenient or even superior to fossil fuel-based vehicles. And once again, within our department, there is a multitude of research activities that are looking at how to ensure affordable and convenient electric vehicles are a realistic solution in the present rather than just a never-reaching dream of the future. Within our department, there is a number of world-class facilities that allow us to understand and emulate the real-world challenges, but also develop and evaluate the solutions for these problems. One of the prime examples of such facilities is the High Voltage Laboratory, which is largest of any UK university. Within this laboratory, amongst other things, we are able to simulate lightning strikes using our 2 megavolt impulse generator. But we're also able to test any component that you would find on a typical electrical energy system used today, but also in the future. Although this is a research facility, which means that it is mostly used by postgraduate and postdoctoral researchers, it is also a teaching laboratory where undergraduate students do their coursework and project work. One other facility that I would like to briefly mention is the so-called real-time digital simulator, which allows us to rapidly develop and implement as well as thoroughly test control systems used in the electrical energy sector. Hope you enjoyed this brief presentation. If you have any questions about anything discussed in this presentation or about undergraduate courses that we offer, then please do get in touch with us. Thank you.